So today we'll talk about homogeneous linear equations with constant coefficients, and we will show you how we solve this kind of differential equations. Okay, as our previous lectures, we said that differential equation in this form, we said that homogeneous differential equation because since we have here zero, our differential equation, our linear differential equation was, we called it as homogeneous linear differential equation. Okay, so if we have here, as you remember in our previous lecture here, in front of derivatives was functions, but today we'll consider case when we have just constant numbers, guys. And since we have here a0, a1, and till an minus 1 and plus a and y is constant numbers from a0 till an, all of them constant numbers, we say that this differential equation is homogeneous linear differential equation with constant coefficients. And let's solve this kind. How we solve this kind of differential equation? Okay, so let's consider second order homogeneous linear differential equation, guys, with constant coefficients. So this one is our second order homogeneous linear differential equations with constant coefficients, because here we have a, b, c are constant numbers, and homogeneous because we have here 0. You know that if you have here function not equal to 0, then we say that this differential equation is non-homogeneous. Okay, so let's consider this case and how we solve this differential equation. Okay, so our equation is ay 2 times prime plus by plus cy is equal to 0. Let's trying to find solution of this differential equation in this form, and so our function is equal to y is equal to emx, e of power mx. Okay, so to check that, let's check is this function solution of this differential equation. To check that, we need to find first the derivative of this function up to second derivative, because our derivative here is equal to 1 and here is equal to, sorry, here is equal to 2, here is equal to 1, and so if we find first derivative of this function is equal to y prime is equal to m emx, and second derivative is equal to m square e of power mx. And if we put this y prime, y2 times and y here, guys, what we have? We have, since we put instead of y2 times prime this function m square e of power mx, we have this one am square emx plus since we put instead of y prime the function m e of power mx, we have pm e of power mx, and plus since we have here just y, we just put this function and we have just c e of power mx is equal to 0 and 0. So as you see, if we take out all of them has a factor, all of them has a term e of power mx, and if we take out e of power mx out of x, we have am. If we collect this one by mx, we have e of power mx am squared plus bm plus c is equal to 0. And what does it mean? It means that our function y is equal to mx will be solution of this differential equation if and only if this term will be 0. So it means that we need to consider solutions, or we need to consider roots of these quadratic equations. Okay, so let's consider this equation am squared plus bm plus c is equal to 0. So if our equation has distinct real roots, so for example, let's define them as m1 and m2, and then a solution of our differential equation in the form a y 2 times prime plus by prime plus cy is equal to 0 will be this function, guys. Okay, as you see here, y is equal to c1 e of power m1x plus c2 e of power m2x. Okay, let's consider the second case. If our if this equation has repeated real roots, or m1, if m1 and m2 are equal, then general solution of this differential equation will be what? Will be this function, guys. Y is equal to c1 e of power m1x plus c2 x e of power m1x. Not that here we have x, but in case our equation has distinct roots, we wrote here without x, as you remember, in the first case. In the second case, here we have add, and in powers will be m1x and m1x, because m1 and m2 are equal. So third case, okay, solution of the uh, equation can be, of course, complex roots. Okay, if we have complex roots, it means that what? Our m1 will be equal to alpha plus beta I, and the m2 will be alpha minus beta I. So, and here I, you know that I square is equal to minus 1. Then general solution of our differential equation will be what? Will be this function, guys. Y is equal to c1 e of power alpha x cosine beta x plus c2 e of power alpha x sine beta x. Okay, so since here we have e of power alpha x, you can take out, you can collect by e of power alpha x, then you have what? c1 cosine beta x plus c2 sine beta x, and this function will be solution of your differential equation. Okay. Okay, let's consider examples of solving homogeneous linear coefficient, homogeneous linear differential equation with constant coefficients. Let's consider example for the case 1. So let's write here case 1. So in the case 1, what was if you have distinct roots, real roots, guys, in your equation, then solution was what? Y is equal to c1 e of power m1x plus c2 e of power m2x. Okay, so your equation was a y to 2 times prime plus by prime plus c is equal to 0, and then we need to consider what? We need to consider this equation am squared plus bm plus c. Okay, so and then we need to consider root of this equation, guys. So let find from let us we have this differential equation, and let's solve this differential equation. Okay, y 2 times prime minus 5y prime plus minus 3y is equal to 0. So what will be solution of this differential equation, guys? Let's solve. So if we write this differential equation, so to solve this differential equation, we need to consider this equation, and in our case, a is equal to 2 and b is equal to minus 5, and we need to write am squared plus minus 5m minus 3 is equal to 0, and we need to solve this equation. What will be root of these equations? And here, from here, we have what? m1 is equal to what? So from here, m1 is equal to minus 1 over 2, and m2 is equal to 3, guys. So let's check. If we put here 3, what we have? 9 multiplied by 2 is 18. 18 minus 5 multiplied by 3, 15. So yes, so if you put here 3, we have 0, and if you put here minus 1 over 2, again will be 0. Okay, so now we found some roots of this equation, and by as we said before, general solution is of our differential equation is this function c1 e of power m1x. m1x is equal to minus 1 over 2x, and the plus c2 e of power m2 is equal to 3x. So now we found a general solution of our differential equation, guys. That's all. So let's consider second example. This example is for case 2. It means that if your equation am squared plus bm plus c is equal to 0, and the root of these equations are equal, then solution was, what was the solution in this case? In this case, solution was y is equal to c1 e of power m1x, e of power m1x plus c2x e of power m1x. Okay, so if we write here, uh, if we have this equation, guys, y2 times prime minus 10 y prime plus 25 is equal to 0. If we want to find solution of this homogeneous differential equation with this constant coefficients, we need to consider this equation. So in our case, what will be a is equal to 1, so that we write here just m squared minus b is equal to minus 10, so here minus 10m plus 25 is equal to 0. Okay, if you find root of this equation, what will be m1 and m2, m1 m are equal to m2 will be 5, guys. Minus 5, just 5, yes, because m1 m sorry m minus 1 m minus 5 square is equal to this equation, so it should be equal to 0. From here we have m1 and m2 are equal. So as we said before, solution of this differential equation will be in this form, and we need to write just instead of m1 and m2 5, so we have c1 e of power, since instead of m1 we need to put 5, we just write here 5x and plus c2x e of power 5x. So now we found solution of our differential equation, and the solution was what? Solution is equal to c1 e of power 5x plus c2x e of power 5x is solution of this differential equation. Okay, let's consider our third example. Consider case 3. In the case 3, we have complex roots. So if this equation has complex roots, such as m1 is equal to alpha plus beta I, and m2 is equal to alpha minus beta I, then our solution of differential equation will be this function. And let's consider, for example, this differential equation, and let's find solution of this differential equation. So what will be in this case a? In this case a is equal to 1, so that we just write m squared plus 4m plus c is equal to 0, and not c is equal to 7, so I need to write here 7. So I need to solve this equation and to find m1 and m2. If you find from here m1 and m2 will be what, guys? So let's find discriminant of this. What will be discriminant here? So here will be what? 16 minus 4 multiplied by 7 and multiplied by 1 is equal to what? Here I have what? Here will be 28, and the 28 minus 16 will be what? 14. Am I right? Minus 14 minus 12 will be minus 12. Okay, and what does it mean? It means that this one is equal to root of minus 3, and if we write here m1 m2, m1 is equal to what? M1 will be minus 4 plus root 2 multiplied by root of 3 and I. So I here is equal to root of minus 1, and m2 is equal to what? M2 is equal to minus 4 plus, here I need to divide by 2, and here plus, not plus, here should be minus root of 2 root of 3i, and I need to divide by 2. This one will be what? This one will be minus 2 plus root of 3i, and here will be minus 2 minus root of 3i. As you see in our case, alpha will be minus 2, so alpha is equal to minus 2, and the beta is equal to I, root of 3. So if I want to write solution, I need to write y is equal to in our case alpha is equal to minus 2. So I write here minus 2x, and the c1 cosine, since my beta is equal to root of 3, I write here root of 3x plus c2 sine beta is equal to root of 3x. So this one will be solution of my differential equation, and that's all. This one is general solution. If you have, for example, here initial value or bound value problem, you need to find c1 and c2 such that your function satisfies your conditions. That's all.